The focus on today's lesson is going to be finding volumes by known cross-sections. Now, we've been doing this all along. The cross-sections have just been either discs or washers, but you know that they don't have to be. They can be squares, they can be rectangles, they can be all kinds of things. And so today I'm going to run through two quick examples, and then you guys are going to get in groups and practice. So this first one says to find the volume of the solid with a given base and cross sections. The base is the triangle enclosed by the line x plus y equals 1, which is going to look like this, right? Y equals 1 minus x. The x-axis and the y-axis. And then the cross sections, which are perpendicular to the x-axis, are quarter circles, which means every cross section perpendicular to the x-axis forms a quarter circle. Now, I'm terrible at drawing these, but you can kind of get the idea. Of what kind of region we're talking about. Okay, so what I need to do is find the area of one of these quarter circles and then integrate that area from 0 to, this is going to be 1. Okay, so the area of a quarter circle is 1/4 pi r squared, and the radius of any of these circles is going to be this distance right here. Well, that distance, top minus bottom, is 1 minus x minus 0. So that's just going to be 1/4 pi, and then that radius is just 1 minus x squared, which means that the volume is going to be the integral of 1/4 pi, and I'm going to put that out front as pi over 4, of 1 minus x quantity squared, as x goes from 0 to 1 with respect to x. Okay, so for each of these, the trick is kind of drawing yourself a picture and figuring out how to write the area of one of those cross sections and then integrating that area. Let's do one more. Find the volume of the solid with the given base and cross sections. The base is the circle x squared plus 9 squared equals x squared plus y squared equals 9, which is a circle with a radius of 3. And the cross sections perpendicular to the x-axis are squares, which means everywhere I have a cross section here, it's going to form a square popping out of the page. Hopefully that looks better on the smartboard than it does on my screen. Okay, so each of these squares, the area of one of these squares is the side length squared, yes? And let's see, the difficulty here is that this circle, x squared plus y squared equals 9, is not actually a function. It's composed of two functions, the square root of 9 minus x squared and the negative square root of 9 minus x squared. So the side length of one of these squares is going to be top minus bottom, which is going to be the square root of 9 minus x squared minus the negative square root of 9 minus x squared. In other words, 2 square root of 9 minus x squared. I'm hoping we can see that here. It's doubled up because I have the upper half of the circle and I have the lower half of the circle. Okay, and so I'm going to have, there's no pi here because we're talking squares. The volume is going to be the integral from x equals -3 to x equals +3 of that side length, 2 square root of 9 minus x squared squared dx. All right, so those are just two examples I wanted to give you. I also want to give you some formulas from geometry that you may not remember. Areas that you need to know are the area of a square, the area of a rectangle, the area of a trapezoid, the area of an isosceles triangle with the base equal to one of the legs is 1/2 x squared. However, if the hypotenuse is what's in the base, then the area is 1/4 h squared. And if you're interested in me showing you where that comes from, I can show that to you later. The area of an equilateral triangle is radical 3 over 4 times that side length squared. And the area of a circle is pi r squared. So once you have these written down, you guys are going to get into groups and you're going to get a worksheet that has some different sets of equations and some different types of cross-sectional areas. And you're just going to follow the directions and you can check your answers with my key up front.